Hello friends, welcome to my YouTube channel. My name is Akash Mandi. Subject Mathematics USN 1V23EC 003. Today we are going to discuss about the topic of periodic function and periodic signal. Periodic functions and periodic signals. This presentation explores the fascinating world of periodic functions and signals. We will dive into the fundamental definition, properties, and application of these mathematical concepts, which play a crucial role in various scientific and engineering fields. Get ready to unwrap the beauty and significance of periodicity. What is periodic function? Definitions. A periodic function is a mathematical function that repeats its values at a regular intervals. This repetition is characterized by a specific period, which represents the length of the interval over which the function repeats. Key characteristics. A periodic function is defined by its period and its amplitude. The period determines the length of the repeating cycle, while the amplitude defines the maximum deviation of the function from its average value. Mathematical representation. A periodic function f of x can be represented mathematically as f of x is equal to f of x plus t, where t is the period of time function. This equation indicates the function values at the point x is equal to its value at x plus 1 period. Key properties of periodic function. Periodicity. The most fundamental property of periodic function is its repetition over a fixed interval, defined by the period t. This means the function's value repeat themselves identically after every period. Symmetry. Periodic functions often exhibit symmetry, either even or odd symmetry. Even symmetry means the function is reflected across the y-axis, while the odd symmetry means it reflected across the both y-axis and the origin. Boundedness. Periodic functions are typically bounded, meaning their values remain within a finite range. The amplitude represents the maximum deviation from the average value, ensuring the function's value stay within a defined range. Integratability. Periodic functions are often integrable, meaning their integrals over a single period can be calculated. This property is crucial for various applications, including the calculation of average values and energy content. Example of periodic functions. Sine wave. The sine function, denoted as sine of x, is a classical example of periodic functions. Its period is 2 pi and it oscillates between -1 and 1. Sine waves are widely used in various applications, including modeling sound waves and alternating current. Square wave. A square wave is a periodic function that alternates between two constant values, often 0 and 1, and it is characterized by sharp transitions between these values and a rectangular shape. Square waves are used in digital electronics and signal processing. Triangular wave. A triangular wave is a periodic function with a triangular shape, ascending linear to a peak value and then descending linear back to its starting point. It's characterized by its continuous slope and its symmetrical shape. Triangular waves are used in audio synthesis, electronic music. Periodic signal in real world. Clock ticking. The regular ticking of a clock is very clear example of a periodic signal. The interval between each tick represents the period, and the sound of the tick can be considered the amplitude of the signal. Swinging pendulum. The motion of swinging pendulum is another example of periodic signal. The period is the time it takes for the pendulum to complete one full swing, and the amplitude is the maximum angle of displacement from the resting position. Ocean wave. The rhythmic rise and fall of the ocean wave can be modeled as a periodic signal. The period represents the time between two consecutive wave crests, and the amplitude represents the height of the wave. Sound wave. Sound waves are another excellent example of periodic signals. The period is the time between two consecutive peaks or throats of the sound wave, and amplitude represents the loudness of the sound. Definition and properties of periodic signal. Definition. A periodic signal is a signal that repeats itself over a time with a constant period. It's characterized by its amplitude, frequency, and phase. Period. The time interval after which the signal repeats itself. It is measured in seconds or any other suitable time unit. Period is denoted by capital T. Frequency, which is denoted by small f. The number of repetitions of the signal per unit of time. It is the reciprocal of the period and it is measured in hertz. Amplitude, which is denoted by capital A. The maximum deviation of the signal from its average value. It is measure of the signal's strength or intensity. Phase, which is denoted by phi. The initial position of the signal at a given time. It is measured in radians or degrees and affect the signal starting point within its period. Relationship between periodic function and periodic signal. Periodic signal. A periodic signal is a physical phenomenon that repeats its behavior over time. It can be represented by a periodic function which mathematically describes the signal characteristics. Periodic function. A period function provides a mathematical representation of periodic signal. It captures the signal pattern, amplitude, and period, allowing for analysis and prediction of its behavior. Connection. The period function acts as a mathematical model for the periodic signal. It allows us to understand the signal properties, analyze its behavior, and manipulate it using mathematical tools. Fourier series representation of periodic signals. Decomposition. The Fourier series represents a periodic signal as a sum of sine and cosine function with different frequency and amplitude. This process breaks down the complex signal into simpler fundamental components. Harmonic. Fourier series representation includes the fundamental frequency which corresponds to the signal's main period as well as its harmonic, which are multiples of the fundamental frequency. Reconstruction. By combining the fundamental frequency and its harmonic with the appropriate amplitude and phases, we can reconstruct the original periodic signal from its Fourier series component. Advantages and application of periodic signal. Signal analysis. Periodic signal can be readily analyzed using the Fourier series, which allow for identification of frequencies, component, amplitude variation, and phase relationship. This analysis is crucial in fields such as signal processing, communication, and acoustics. Signal generation. Periodic signals can be generated using oscillators and waveform generators. This ability is essential for creating and manipulating signals in various applications, including communication, audio systems, and control systems. Signal processing. Periodic signals are extensively used in signal processing where they are manipulated, filtered, and analyzed to extraction information or enhance the specific characteristics. This includes application in audio processing, image processing, and data analysis. Real-world application. Periodic signals find widespread application in diverse fields. These include communication system where they can carry information, musical instrument where they produce sound, and electrical circuit where they control and regulate system behavior. Summary and key takeaways. This presentation has explored the fundamental concepts of periodic function and periodic signals. We have learned about their definition, properties, example, real-world application. We have also explored the connection between periodic functions and periodic signal. Understanding how periodic functions provide a mathematical representation of periodic phenomena. Key takeaway includes Periodic functions repeat their values at regular intervals, defined by their periodicity. Periodic signals are physical phenomena that exhibit repeating behavior over time. The Fourier series provide a powerful tool for analyzing and representing periodic signals. Periodic signals have numerous applications in various fields including communication system, musical instrument and electronic circuits. Thank you.